Hello, welcome to my video about Raspberry Pi applications in a smart home. Here at the top right you see my home and every blue dot is a Raspberry Pi. Here in the table below you see all the functions I integrated into the various Raspberry Pis, and you see that usually one Raspberry is serving several features. Below I have some pictures, and after you have seen that, I think you will understand why I'm so amazed of using the Raspberry Pi in my house, in my smart home. Here you see LED stripes for ambient light, which I'm using and operating with the Raspberry Pi. Those LED stripes are of the kind SK6812W, where you can address every single LED individually, so you can create a lot of effects. And those effects I fully control for each individual LED on the stripe by my own software with my own Python code. So I can do a lot. The next item I want to show you is my smart door. There actually is a separate video on that. I have several contact sensors, and with two relays I operate the electric motor and make my lock smart for the security bar. Then in the bathrooms I have some Raspberry Pi Zeros hidden in the wall. Here one is hidden in the fan and it actually operates the fan. And here in the other bathroom, the Raspberry Pi is measuring the air state, temperature, pressure, and humidity, and it's a motion sensor. Of course, also here, on top of controlling the fan, the Raspberry Pi has a motion sensor and it's measuring the air temperature, humidity, and pressure. This is my aquarium. As you may guess, over here it's a saltwater aquarium. Over here the small black box, that is the Raspberry Pi. Very close to it here, outside at the back of the aquarium, there is an air state sensor measuring again temperature, pressure and humidity. Here there is a rotation sensor connected to the Raspberry Pi. And every time the filter floss is rotating, the Raspberry Pi is measuring that and can forecast when it will be empty and need to be replaced. Down here at the bottom of the aquarium I have a water sensor. You see it here, so if there is some leakage, the Raspberry Pi will note that and create an alarm. Here in the water I have a water temperature sensor. It's connected to the Raspberry Pi with a one-wire bus. And so the Raspberry Pi actually controls the heater here. So when the water temperature drops below a certain level, the heater is switched on. And once the water is warm enough, the heating will be switched off again. So I'm not using the mechanical kind of stupid thermostat in here. I can control the heating and the water temperature by the Raspberry Pi. So we need to go back, there we are. Here I have a water level sensor, and this is the ATO, the automatic top off, and if the water by evaporation, water level drops too low, then water is refilled. So there is a sensor, and the sensor by my own software of course activates a 5-volt pump, which is connected to the Raspberry Pi with a power transistor to the GPIO. So if water drop, fresh water is clean water is pumped from this box into that box to refill. Over here, by the way, I have an NFC tag, which is of course not connected to the Raspberry Pi. So if I replace the filter floss or if I refill the box here, then I scan the NFC tag and I can enter the water level, or I can reset the filter floss to a new one. So here it's a lot of functions integrated into only one Raspberry Pi, and it's amazing how reliable it works. And bottom line, once you manage the different elements, it's not so complicated. Of course, the harness in here, as you can see, that is a little bit of a mess, I agree. Here, with that Raspberry Pi, I only operate a relay in a power line. And this is very simple, nothing magic on that. You could also use a smart plug from the shelf. Only advantage here, it's hardwired to the LAN of my flat. It doesn't consume Wi-Fi resources. And of course, it's fully local. Yeah, no app, no remote service, nothing. So very fast, very reliable. But I agree to use a Raspberry Pi only to operate a relay is a bit of oversized. I have the fridges controlled by a Raspberry Pi, so a very thin cable goes into the fridge. Here is a temperature sensor. Again, a one-wire bus system. Very good measurement, very accurate, very reliable. This Raspberry Pi also is measuring air temperature outside and pressure and humidity. Here you see the temperature measurement in the fridge over time, and I have a special chapter on that in my wiki. Here you see how I measure the wind speed on my balcony. I have this anemometer outside. Inside of it there are two contact sensors, so if it makes one rotation it sends two signals. And I created my own software to analyze the signal and convert it into wind speed in kilometers per hour and in Beaufort. When there was a very strong wind, a storm, this wheel is anemometer rotating extremely fast. It's not visible anymore because it's so moving so fast. So I was a bit afraid that the Raspberry Pi may be too slow to measure the wind speed if wind is very high. That would be a risk, of course, if the high, strong wind could not be measured. The alarm would not be sent, the action would, oh, no. So I made analysis, I measured the cycle time, and actually an old simple Raspberry Pi, I think it's a B version, it could detect the sensor signal of the two sensors in here 30,000 times per second. I have been thinking a little bit and I thought, well, this wheel will never turn 15,000 times per second. That's impossible. So the Raspberry Pi is capable of the highest wind speed, I think, which it will be exposed to over a long period of time. Here you see very interesting how I operate the garage doors with Raspberry Pi. Actually, in the house, in the basement, there are 3 garages. Every garage door has a contact sensor to detect whether the door is open or closed. And these cables here go to the contact sensor. You see 1, 2, 3 pairs. Yeah, that's simple. I can also open 2 of the doors with a remote control. And here I abused a remote control, which usually has a battery and you press it by hand to open or close the door. So I took out the electrical inside and mounted it into the cover of the Raspberry Pi. I've connected the power from the Raspberry Pi to the power of the remote. And here, that is the switch. So if you press a button, inside you press this little mini button. Here you see it magnified. And I mounted a soldered a GPIO signal to the pin of the contact sensor here. So now when I set the GPIO to the up state, I can simulate somebody pressing the button. So then the remote is transmitting the signal and the garage is receiving it as I would have pressed the button myself on the remote. That was an experiment I did several years ago, and here in that house we have 13 parties living in it. And several of them are using that now with a remote web page where you click a button and you can open or close the garage door. It's very convenient. There is a safety connected to this for accidental opening by the software by mistake or for hardware defects. And I will soon make a special video on that, how for security reason I avoid opening or closing the door, either accidentally or by a software or hardware mistake. I think that is also a very nice, interesting application of a Raspberry Pi. The last item I have some photos about is the central heating. So there I use one-wire temperature sensors again at different places of the central heating, so I can see the development over time of the temperature. I can define upper and lower limits and can analyze it and send error message and warning in case the heating has a malfunction. Usually my experience here is very good. When something is wrong with the heating and I call the craftsman, I can explain to them exactly what happens. I have detailed information about the problem. So this makes the solution, the repair, easier, quicker, and less cost. And within this house, as I said, of 13 parties, it's very convenient to have facts and figures instead of thinking, belief, and emotions. Bottom line, the Raspberry Pi is very cost efficient, very nice because they are fully local and very flexible and can integrate a lot of hardware. I perhaps made you curious to look into my wiki. There is a lot of other pages. You find the address of my wiki in my channel. And I will also link the address of that particular wiki page in the description below of that video. Thank you very much for listening. See you again. Bye bye.